Find the value of delta such that given epsilon equals 0.15, the function 3x plus x squared has a limit of 10 as x approaches 2. Your first step is to set up this inequality, which is 10 minus epsilon is less than f of x, which is less than 10 plus epsilon. So then you plug in everything for the next line, which is 10 minus 0.15 is less than 3x plus x squared, which is less than 10 plus 0.15. So you wind up with an inequality that says 9.85 is less than 3x plus x squared, which is less than 10.15. So then you separate your inequalities and you wind up with two different equations, inequalities, that says 3x plus x squared minus 9.85 is greater than 0, and 3x plus x squared minus 10.15 is less than 0. And then you plug both of those into your calculator. Using polysmelt, you get these answers. You cross out the answer for the inequality that is farther away from x approaching 2. So you keep x equals 1.9785 and x equals 2.0214 because they're the both closest to 2. Your next step, as seen on the right side of the page, is to take the absolute value of 2 minus both of your values, and that is what delta equals. So you get delta equals either 0.0215 or delta equals 0.0214, and you take the 0.0214 because it's the smaller value, and that's what delta equals. The next problem is a related rates problem, and it says a kite 150 feet above the ground is being blown away from a person holding its string. It moves parallel to the ground at a rate of 15 feet per second. At what rate is the string going out when it is already 280 feet? When solving this problem, your first step is to draw a picture. The picture I drew is a right triangle, and its vertical leg is labeled y, and it's 150 because that y represents the height of the kite. Its hypotenuse is labeled z, and it's labeled 280 because the hypotenuse represents the string of the kite, which we know is 280 feet because that's given to us in the problem. And then its vertical leg is x, so you have to find x because that's not given in the problem. So under the triangle, I just wrote find x, and you use Pythagorean theorem to find x, and you get 236.43818. Now, because you know the rate of change for x, dx dt is 15 feet per second because you differentiate it implicitly with respect to time, so that's where you get dx dt. And your goal is to find the rate of change for the hypotenuse, z, so you need to find dz dt when z equals 280 feet. So actually solving the problem is seen all the way to the right of my page, and you use Pythagorean theorem, x squared plus y squared equals z squared, and then since you're given 150 for y in the problem, you substitute that out, so you do x squared plus 150 squared equals z squared, and then you take the derivative and you implicitly differentiate with respect to time, so you get 2x dx dt equals 2z dz dt, and the reason the 150 squared goes away is because it's a constant. So then you plug in all your values that you already have, and you have for x 236.4318 and 15 for dx dt, and you have 280 for z, so the only variable in this equation is dz dt, and you do all the math out in your calculator and you do the algebra and you come up with 12.6660 feet per second.